The Beauty of Coding Snowflakes. Here we go. My name's Elaine Wolfe. I'm a former math teacher with a degree in computer science. In May of 2021, I joined an online tea and TurtleStitch workshop with instructors Cynthia Solomon and Susan Klimchak to learn how to code in TurtleStitch. It was an amazing 6-month journey with 2 fabulous instructors and a wonderful community of fellow teachers. On this journey, I rediscovered my love of coding. I'm presently a content creator and I post all of my work on my blog, papercraftetc.blogspot.com. In this SnapCon 2023, I realized there's been a lot of talk about how to teach programming. And in my talk, I'll be presenting a solution for engaging elementary students in learning to code TurtleStitch. My solution is a multidisciplinary one. I explore the topic of snowflakes through science, literature, mathematics, and computer science. In coding the snowflakes, I explore the different ways to code to have the same outcome. Too often, students think there's only one solution to a problem. I also use scaffolding to teach coding. Each subsequent TurtleStitch program builds upon the previous program. Snowflakes are a thing of beauty and wonder. Ideas for TurtleStitch come from the nature around us. Imagine walking through a forest on a cold winter day with snowflakes falling from the sky. There are hundreds of millions of them falling gently to the ground. You reach out and touch one with your gloved hand, and there lies a perfect snowflake in all of its wonder. But wait, the next snowflake looks just as beautiful and unique as the last. How can this be? How can each snowflake be more beautiful and different than the last? Looking closely at the structure of a snowflake, you'll see that each snowflake almost always has 6 points. Occasionally there's an anomaly and it will only have 3 points. Why is this true? You may ask. The answer is in the structure of the water molecule. Water is made up of 2 hydrogen atoms and 1 oxygen atom, H2O. Each snowflake is made of billions of water molecules, and at the core are water molecules that are holding hands. These water molecules at the center create the 6-point structure or hexagonal shape. Atmospheric conditions such as temperature and humidity change the structure of the forming snowflake, but the core shape always remains the same. An interesting book about snowflakes is Snowflake Bentley by Jacqueline Briggs Martin. The book depicts the true story of a child named Wilson Bentley who was fascinated with snowflakes. Bentley's enthusiasm was misunderstood at the time, and people used to make fun of him. His patience and perseverance of looking at snowflakes under a microscope was rewarded when his parents gifted him a camera to document the uniqueness of the snowflake shapes. In 1885, he photographed the first snowflake in Jericho, Vermont. He went on to photograph and publish a book about snowflakes. Wilson Bentley, a self-taught scientist, was the first person to claim that no 2 snowflakes are alike. And here's a download link to a lesson plan if you would like to use this book. The TurtleStitch snowflake. The mission is to create snowflakes using TurtleStitch. Start with making a 6-spoke structure. A spoke is just a straight line. Here are 2 ways to make a spoke. It doesn't matter which one that you choose. This one, move 100 steps and then go in the negative direction, a negative 100 steps, will just move the turtle to the one side and then back. Here you're saying move 100 steps and then turn 180 degrees in the opposite direction and move another 100 steps. Notice that the turtle is pointing in 2 different directions. What will this do for coding the next turtle position? The turtle will need to be turned differently. Coding a snowflake. Since a snowflake is a 6-sided figure or a hexagon, the next step is to place the spokes evenly in a circle. There are 6 spokes. We know that a circle is 360 degrees, so that we want the turtle to turn 360 divided by 6, which is 60 degrees. Here are two versions of code for a snowflake. They both produce the snowflake at the right. And you'll notice that the different code, and what I want students to see is that you can make the same outcome, but using different code. Comparing coding techniques. Compare the snowflake code with just after one repeat. So we move 100 steps, and then we went back 100 steps, and then we turned 60 degrees. And here was the starting point. So in the screen capture on the left, it appears that the turtle moves a greater distance than the code on the right. However, the turtle on the left needs to traverse the same line to get back to the center. The screen capture on the right, the turtle has already traversed the same line twice and is positioned to move. The distance traveled in both cases will be the same after 6 repeats. Another difference is the turtle travels in a clockwise motion in the screen capture on the left, and the turtle moves in a counterclockwise motion on the right. More comparisons. In the first set of blocks, the snowflake is created by the moving turtle 100 steps and then moving minus 100 steps. Notice that the turtle turns 60 degrees after drawing a spoke. In the second set of blocks, the turtle is moved 100 steps, turned 180 degrees, and then moved 100 steps back to return to the center of the figure. The turtle is then turned 120 degrees to complete the first spoke of the snowflake structure. Why was 120 degrees used instead of 60 degrees? The answer is in the direction in which the turtle is pointing. This is an important concept in TurtleStitch and is hard to envision without an example like this. The move is different because it's an interior angle. In the figure shown, the blue area represents the interior of the hexagon. The angle Y forms a 120-degree angle. The angle X, it represents the exterior angle, and it forms a 60-degree angle. Both sets of code accomplish the same result. It is interesting to see mathematical concepts come to life with the move of a turtle in TurtleStitch. For future reference, to calculate the move for a polygon of n size, the interior angle formula is 180 minus 360 divided by n. Adding an endpoint to the snowflake spoke. A square was added at the endpoint of this snowflake. The first is only 45 degrees, the first turn is only 45 degrees to set the square diamond into position. The next 3 turns are 90 degrees to complete the square. There's a 45-degree turn to return to the center of the snowflake. Since the turn is an interior angle, it is a 120-degree turn to get to the next spoke. Repeat this code 6 times. And then you also show that there's nesting here. A diamond was added as an endpoint to this snowflake. The first turn is only 30 degrees to set the diamond into position. The next 3 turns are 60, 120, and then 60 degrees to complete the diamond. There is a 30-degree turn to return to the center of the snowflake. Since the turn is an interior angle, it is a 120-degree turn to get to the next spoke. Repeat this code 6 times. Comparing 2 methods of adding circle endpoints to the snowflake spoke. This code required calculations to make the circles, center the circle at the end of the spoke, and then realign it. Both sets of code produce circles at the snowflake spoke, but one is easier to code than the other. This code is the simplest. Once the line is drawn, the turtle is coded to move 90 degrees. This will align the turtle in the correct position. The arc block takes care of the alignment calculations. Here are some snowflakes that were created in TurtleStitch. In each snowflake, a different feature was added with a turn or a move. As in nature, snowflakes can become very complex structures. Making a snowflake with branches. This one was reimagined by Marcus Gailey's snowflake program. The first move is 10 steps to move away from the center of the snowflake to eliminate density warnings. Looking at the code, the interior loop of repeat 10 means that there are 10 branches on each spoke at a 60-degree angle to the spoke in 50 steps. I did not use a pen up or down when moving the turtle along the branch because I wanted some thread weight to each branch when the snowflake was being embroidered. I turned 180 degrees minus the angle measure to get back to the center of the spoke. I repeated the 60-degree angle move to the other side of the spoke for each branch. So these are branches on one side, and then there's branches on the other. Okay, once the 10 branches were made, the turtle was moved back to the center of the snowflake. This spoke code was repeated 6 times to complete the snowflake. The overlying branches in the center of the snowflake produce the interesting pattern in the center. So these are just overlying, and that pattern was created that way. Now, I've taken that previous program, and it's exactly as the same, but I used numerical values. Except the numerical values were replaced, and you can see that I replaced them here. This type of coding makes it easy to change values of different variables without having to change the logic of the code. So going on. Continuing the quest to code beautiful snowflakes, this program is exactly as the previous one, except variable names were given a range of values with the pick random block. This generates random numbers between the numbers that were specified. Each time the program is run, a different randomized snowflake is created with different number of branches, with different angles at which the pair of branches intersect the main spoke, different branch lengths, and different spacing between the branches. If you like a certain snowflake, write down the randomized number that created the snowflake to recreate it. Remove the pick random block and replace it with the values that you like. The values are shown in the stage area. Okay, and then this is another iteration, and this is the last one. This program generates 9 random snowflakes because I have 2 nested for loops, which create the rows and columns. And this for loop is in the drop-down library. The next for X value represents the rows, and the for Y value represents the columns. The interior for loop is executed first to create 1 row of snowflakes, and the exterior for loop is then executed to create 1 column of the snowflakes. The code bounces back and forth between the for loops until all the conditions are met. So once all the snowflakes were made, you can make an ornament out of it. And it's been, I coded a satin stitch around the snowflake, and I added a circle here to as a hanger. And craft felt was used with tearaway stabilizer as backing for the design. Once embroidered, the design was cut about 1/8 of an inch from the satin stitch. It's not recommended to cut any closer, as a slip of the scissors might cut the satin stitch threads. A bow and a thread hanger were sewn to complete the snowflake ornament. And here's the resulting, I designed these 2 snowflake ornaments with randomly generated code. So yes, is there any questions? Let's see, I will stop this. Okay. Exit slideshow, and I will go to my Zoom. Where's my Zoom? Sorry, stop share. Okay. All right, so yeah, are there any questions in that? I know it was very simple after everybody had such complex programs, but you know what? This program, my workshop, I call it a snowflake workshop, is really meant for 4th graders. So I know it's a very simplistic program that I presented, but you know what? Students have to start somewhere. And I think with TurtleStitch, it's a wonderful way to get them excited about programming, and also with multidisciplinary approach where, you start with literature and you start with just imagining what a snowflake is, and it gives students the wherewithal to stick with the coding and to make beautiful snowflakes. So thank you.